everyone. So the first method that we are going to study about is the bisection method that falls in the first module. I feel the best way to study about something is by practicing it. Here I will explain the entire algorithm along with solving a problem. Our problem is find the root of the equation x square minus 4x minus 10 is equal to 0, and here we are going to use bisection method. The step 1 is find a0 and b0 or the initial values that we begin with such that fa into fb is less than 0. Hence we will find out x, which will be a plus b by 2. So how do we find this? Our equation is fx equals to x square minus 4x minus 10. Let's take a value f0. So that will be 0 square minus 4 into 0 minus 10. That is minus 10. We want two values such that fa into fb is less than 0. If one value is negative, the other value has to be positive. So let's find out f of 1. 1 square minus 4 into 1 minus 10. That is minus 13. We see the value becomes more negative, which is what we don't want. So let's move to say minus 1. That is minus 1 whole square minus 4 into minus 1 minus 10. That is 1 plus 4 minus 10. That is minus 5. Alright. F of minus 2. Minus 2 whole square minus 4 into minus 2 minus 10. That is 4 plus 8 minus 10. That is 2. So we get a positive value here. So let's take a to be minus 1 and b to be minus 2. Let's not take a bigger interval, say 0 and minus 2, because that is only going to increase our work. Hence x will be a0 plus b0 by 2. That is minus 1 minus 2 by 2. That is minus 1.5. So we have successfully completed step 1 of the algorithm. We have to remember that we are taking two extreme values for the equation. One where the value is negative and one where the value is positive. We have to find out that value where the value of the equation fx will become 0. Hence we find out the middle value. Now what we have to remember is if fa into fx is less than 0, root lies in this region. Whereas if fb into fx is less than 0, then the root lies in this region. Using this, we are going to create our table and move forward with the procedure. Our table will consist of these 4 columns: xa, which is the value on the left hand side, xb, value on the right hand side, xm, which is the middle value, and f of xm to find out whether the value is positive or negative. Let's recall that f of minus 2 is a positive value, that is why I've put a plus here, and f of minus 1 is a negative value, and that is why I have put a minus here. We find out that f of xm is minus 1.75. We know that one value has to be positive and the other has to be negative, right? So let's replace this value with xm. So this positive value stays positive. Here we put minus 1.5. Now we find out xm as a plus b by 2, which comes out to be minus 1.75, and f of xm, where we put the value of xm in the equation, x square minus 4x minus 10. This gives us a value 0.0625. Now this is a positive value. We need a positive and a negative, so let's remove this one. So we get minus 1.75 here, minus 1.5 remains. We find out the middle value between them, which is minus 1.625, and then f of minus 1.625, which is minus 0.859. Again a negative value, so we replace this. So we write minus 1.75 here, and this value comes here. You can see how we are converging, and ultimately we will find out a value that matches our result. So the middle value between them is minus 1.6875. F of this value is minus 0.40. Again a negative value, so we replace this. So this is minus 1.75. Here we get minus 1.6875, and the middle value between them, that is minus 1.718. F of x of this is minus 0.170. We have to continue this till we get a value which is almost equal to 0 in this column. Alright, again a negative value, this stays the same. Here we put minus 1.718, middle value comes up to minus 1.734, and here f of this value will give us minus 0.0572. Close, but not that close. Again a negative value, we remove this. This is minus 1.75, get minus 1.734 here. Middle value is minus 1.742, and the value here is minus 0.00256. Now this value can be considered almost equal to 0. Hence our approximate root will be this value right here. So we can write that the approx root of the result is minus 1.742. This is how the bisection method works. Thank you.